Hello, everyone. This is Colleen Milton, and on behalf of WhiteSource and 451 Research, I would like to welcome you and say thanks for attending today's webcast titled New Research Reveals Key Strategy to Manage Open Source Security. Leading off the discussion today will be Scott Crawford, who is Research Director at 451 Research. Following Scott will be Rami Elvan, who is Senior Director of Product Management at WhiteSource. Just a few quick housekeeping items before we get started. To ask a question, simply type it in the question box on your screen below. We will answer as many questions as we can during the Q&A session, and we'll respond to all unanswered questions via email after the webcast concludes. This presentation and slides are available for download. And finally, please provide feedback at the end of the webinar. And with that, I'll turn it over to Scott.
Thank you, Colleen, and welcome everyone to today's webcast. We're going to talk about a trend that has really dominated technology in the last few years, not least because we see so much of technology being driven by one primary aspect, and that's software itself. We see technology becoming increasingly pervasive throughout every aspect of life, from trends such as the Internet of Things beginning to drive the experience of digital life farther into everyday physical life in the physical world, from the personal to the global, and certainly at the enterprise. And that technology is driven by one primary aspect, and that's the software that powers it. In 2011, venture investor and entrepreneur in his own right, Mark Andreessen, made the comment that, as he said, software is eating the world because it is what powers everything that we see in digital technology. 5 years later, when his venture fund was raising their fifth fund, he noted that software will program the world, and this has a lot to do with the fact that the domain of software is beginning to embrace the hardware aspects of IT as well. The progress of virtualization has led to a situation where we now have infrastructure that's rendered as virtual infrastructure, and that means as software. So there's a lot of IT that can be programmed directly as software because software itself is inherently programmable. This combination of factors has created a demand for software as never before, and that demand is not being easily sourced, certainly not by internal development, just within organizations that are building their own software. In fact, a lot of what we've seen in terms of the technology evolution, from virtualization down to the level of the operating system itself, has been driven by a community precedent, an open source precedent, meaning that communities develop software and share it on specific terms, but they share it with the broader world. And we've seen this for the last 20 plus years with the Linux operating environment. And we've seen the rise of what you may consider collaborative development in the rise of these technologies as so-called open source. More recently, we've seen the rise of shared repositories for this software and the phenomenon that GitHub refers to as social coding. GitHub itself has become a repository for software that's shared among a number of people. There may be organizations that are primarily responsible for maintaining certain aspects of software and certain repositories, but the fact that in many cases virtually anyone could access these repositories, make their contributions in concert with the aims of the community, and share them out again with many others, has led to this phenomenon that is doing much to solve the demand for an increasingly software-hungry world, to the extent that we see open source becoming a dominant factor in the evolution of technology going forward. And much of what we see in terms of the evolution of technology being driven by open source itself, concepts such as containers, for example, new technologies that are arising to remake the nature of IT in the enterprise and beyond, largely falling back on reliance on this concept of open source and shared repositories to advance. As we move up to today, we've seen that not only has technology become highly dependent on open source software, but also become highly dependent on shared repositories that make the software available. In fact, just this year, we have seen one of the world's largest technology providers, Microsoft, announce its intention to acquire GitHub for $7.5 billion. And GitHub itself reflects the growth of this trend with 28 million developers, 85 million code repositories. That number has increased substantially just in the last few years. And now with the Microsoft acquisition, we can actually hang a value on this repository, and Microsoft has to the tune of about $7.5 billion, which is testament to the extent to which open source has come to dominate the evolution of technology. But open source itself is not without its own risks. And just to start with one, if you think about the nature of licensing that governs open source software, many people assume, and often erroneously assume, that the ability to make use of the software and implement it in their own products and their own development is unlimited because the software is in many cases free. And that may not be the case. In fact, the definition of free itself may depend on the specific licenses that apply, and there may be multiple licenses or multiple understandings of licensing that apply to the use of open source software. In fact, the Open Source Initiative, whose logo we see here, notes at least 83 different schemes for licensing of open source software just on their site alone. But that doesn't answer questions that get raised when open source is included in technology development, such as what about sub-licensing? If I use an open source module, or if I'm using a module that contains additional open source governed by licenses that I may not be aware of, what are the implications for me as an organization? What are the implications if what I've developed becomes used downstream by someone else? What about the case where if the software is being distributed on a free basis according to its licensing, but it gets folded into a product for which a company charges and becomes a commercial product, what applies then? What kind of risk do I have if I'm using that sort of software and that sort of licensing in my own products? These questions come up all the time regarding open source licensing, and organizations need a way to have visibility into these issues in order to do a responsible job of development with open source software. But licensing is just one of the risk issues that's come up in recent years, and probably one of the most substantial that we've seen in the last couple of years has been security. And a lot of this became very evident with the rise of the Heartbleed vulnerability, Heartbleed bug, if you will, which was first incorporated in OpenSSL back in 2012, but was not discovered and disclosed by researchers until 2 years later. And by the time that discovery was made, it was reported by some that the exposure, which effectively makes it possible to gain access to the sensitive information that users of OpenSSL believe is being protected by encrypted communications by OpenSSL, in fact, is vulnerable to being discovered thanks to this bug. And 17% of secure websites, meaning those that use SSL or TLS variants based on the OpenSSL package, had the exposure of this vulnerability and ran the risk that the sensitive information being handled in encrypted communications could be exposed. And it's not just websites using SSL or TLS. It is also commercial products. In fact, Cisco, at the time that the bug was first disclosed, noted that it had at least 78 different products affected by the Heartbleed issue. But there's also the pervasiveness of exposure that becomes an issue with security. In fact, we saw this particularly with the Struts 2 vulnerability. Now, OpenSSL is a widely implemented and deployed software package, and for that reason, that's why we saw it the pervasive exposure of this vulnerability across so many products and IT services. Struts further emphasizes this by exposing what for many websites is a fundamental component of website architecture in the way that remote commands are often handled by Java-based websites. Struts itself extends, and just to kind of give you an example of how interwoven these software vulnerabilities, relationships, and dependencies can become and the impact they can have on risk, Struts 2 essentially extends the Java Servlet API. And it had a vulnerability in a component called OGNL, the Open Graph Navigation Language, which exposed it to a remote code execution exposure. OGNL is incorporated in the Jakarta package, which is itself part of the Apache web server package. So you can see how these interrelated components of software and complex architectures like modern web applications can lead to exposures that can be very difficult to untangle. If they're embedded in a website, it's possible that the entire website may have to be rebuilt. Its dependencies may have to be refactored. There's a lot of moving parts to resolving vulnerability exposure in these cases. And this was directly implicated in one of the most high-profile data breaches of last year at Equifax, where the breach was discovered in late July, but the vulnerability itself had been disclosed in early March, which had given attackers an opportunity to exploit this vulnerability, which they did in the Equifax case, with the result that we have seen with the number of personal records exposed. So as we look at these challenges, one of the technology areas that we've seen arise in response to handling these issues is a domain known as software composition analysis. And basically that is technology that will inventory open source software within a given environment, correlate that with knowledge of vulnerabilities and risk issues involved in that software, including licensing issues, discover and track those vulnerabilities, and distinguish among versions of a particular software package, because vulnerabilities, of course, are remediated often in further releases of software. And for a project to incorporate a vulnerable version of that software, that can be avoided if you know which version of software you're incorporating or planning to incorporate in your project. Software composition analysis, or SCA, can be aware of these issues and help developers prevent these issues from becoming incorporated in new software projects. In fact, OWASP itself, the Open Web Application Security Project, has identified as part of the top 10 using components with known vulnerabilities. Software composition analysis technology helps organizations be aware of these vulnerabilities before they incorporate them in their software packages. And it further helps to ease the process of integrating this technology and this visibility into new projects by integrating with modern tool chains for Agile and DevOps environments, and helping organizations to embrace more secure adoption of open source software through this visibility and control. So some of the key features of SCA, first of all, the ability to inventory software and to build what is known as a bill of materials, often abbreviated BOM, from multiple sources, meaning multiple sources of software packages, repositories that organizations use to store and manage their software, and track the versions of the software in use, and to do this in a way that gives very wide visibility, as well as very detailed visibility into software components that organizations use or are considering using in their software development efforts. One of the key aspects of SCA that makes it useful to organizations is its breadth of coverage, its ability to cover multiple languages, as well as integrate with multiple tool sets in development life cycles, development and increasingly operational life cycles, considering that, again, infrastructure is often deployed as software in environments like containers, for example. The ability to take action at multiple stages of software and technology development, deployment, and operations. And this notion of shifting left, which implies the increased role of the developer. If you look at DevOps and development of software as a pipeline, moving from left to right, from concept to development to build, test, and then deployment and operations towards the right, we talk a lot about shifting left and shifting more of the emphasis on security towards the development side of that spectrum. But shifting right means that packages that are built to be deployed in operations like containers that include key aspects of the operating system and operating environment combined with the application itself, we see software composition analysis becoming involved at that right end of the spectrum as well too, because again, containers, for example, are software and they are based often on open source components. So SCA has a role all the way from the development of new software based on open source packages to the deployment of software in operations. Today we see that affecting containers. We see that embracing concepts that we see emerging today, such as serverless and service meshes. So we'll continue to see this increase in pervasiveness of software composition analysis throughout the development lifecycle, development and operations lifecycle going forward. One of the things that SCA provides is this analysis of the security of software packages in depth, and not just correlating packages with vulnerabilities that are known and recorded in repositories such as the U.S. National Vulnerability Database, for example, because those vulnerabilities are already known, disclosed, and cataloged in the NVD. Oftentimes, a software composition analysis provider will conduct its own research, as it should, because organizations need to be aware when these vulnerabilities are being incorporated in packages that they're using or considering, so they can make decisions as early in the development lifecycle as possible to remediate these issues or not incorporate vulnerable packages to the extent that they can. Another issue is being aware of dependencies in software. Open source packages may be complex, as we alluded to in looking at the struts vulnerabilities, and may include other packages as part of the overall package. And software often has dependencies on other packages. These dependencies may not always be known to the developing organization, but SCA can give visibility into these dependencies and help organizations be aware of where they exist. Another very useful aspect of SCA that's come to the fore in recent years is this concept of effective exposure, meaning, does a vulnerability necessarily have an impact, or does it expose the organization if the vulnerability is in an aspect of a software package that is not being invoked in an application or is otherwise protected from exposure to potential exploit? The ability to distinguish effective exposure in a development project or in an operational package has the ability to help organizations not pull the emergency brake, if you will, and bring development to a halt, which could have a real dire impact on development pipelines and expectations were that to happen in each and every case. So discerning effective exposure helps organizations get a better handle on when and how it can remediate exposures. In fact, remediation guidance is one of the key features of many approaches to software composition analysis today. How do I fix this? Where can I fix it? How can I best resolve this with the minimum impact on my organization and on my people? And again, coming back to what we started talking about early on with respect to licensing, SCA can give organizations clarity on the actual licenses in use by identifying the software packages in repository, in development, in operations. It can clarify and help lay out for organizations the nature of licensing that actually applies to the software as it's being used. And that's one key point to note, because the way the software is being used may be different from the assumptions that the organization has about how they were using the software and the licensing involved. Actual use may be quite a bit of variance from those understandings and can help organizations protect themselves from potentially abusing licensing in those cases. Licensing can have a severe impact as well on things like mergers and acquisitions. As part of due diligence, an organization that's contemplating the purchase of another wants to be aware of the nature of the intellectual property that they're acquiring, and they need to be aware if that IP is being encumbered by licensing issues that could have a detrimental impact on the business and on the acquisition itself. So we see SCA becoming involved as part of technology due diligence in M&A as well. We see organizations, here at 451 Research, we see organizations adopting software composition analysis. In fact, nearly half of the respondents that we surveyed earlier this year are planning or are using or planning to deploy software composition analysis to deal with these issues. And in fact, among all those that we had seen, quite a few of them not already have it in use, but are also piloting the use of software composition analysis as well. So this is an uptick that we've seen in the adoption of this technology for all the reasons that I've just described. We see an increase in spending on software composition analysis as well. Nearly half of all those reporting SCA in use or in pilot say that they're going to increase their spending, and some of those are going to be making significant increases in SCA spending. So this is a technology that organizations do need to be aware of. And to talk about that and to share his perspective on the evolution of this need, and also about research that WhiteSource has on the nature of open source vulnerabilities, is Rami Elron with WhiteSource. And at this point, let me turn the call over to you, Rami.
So thank you, Scott. Hello, all, and thank you for joining this session. I would like to start with a few words on the overall topic at hand. The significance of open source software development, especially in the modern marketplace, cannot really be overstated. Nonetheless, I believe that the prevalence of open source in the contemporary development scene has also resulted in a growing attention to security, especially given the rise in reported open source security vulnerabilities. Now, attaining software security objectives with open source development requires measures that are not identical to those traditionally demanded by proprietary code development environments. And managing open source security calls for a strategy. This strategy must be able to accommodate unique facets that are emblematic of open source security special requirements. This session really sets out to present salient observations concerning management of open source security. A new research by WhiteSource offers an informative review of that subject and analyzing information that was obtained from hundreds of developers coming from North America and Europe, which was combined with data that was culled from the WhiteSource database. Combined together, the research sheds light on the objectives, on the challenges, observations, and perhaps importantly, the practices that are associated with the management of security vulnerabilities in open source development. So let's please move to the first slide to basically begin our review of the subject in greater detail. Open source risk is on the rise. It is on the rise due to several reasons. One is higher usage of open source components in software development. Another one would be an increasing count of reported open source security vulnerabilities. But perhaps even more importantly, unawareness to threats that are associated with poorly managed open source development processes are key, as well as an inadequacy of traditional tools and practices that are normally required to accommodate the needs of open source software development. Let's please move to the next slide so that we could review some of the key factors driving the increased sense of risk and also to observe certain notable effects. So the software industry is arguably more competitive today than ever. It spurs innovative processes that fuel productivity and agility as well. By enabling software developers to be more productive, open source is increasingly being embraced by organizations all over the world. Consequently, in the past couple of years, there has been a dramatic surge in the attention devoted to open source risk. One could discuss a market perspective where notable observations would include increased analyst coverage, a burgeoning research team recognition, expanding organizational interest, and perhaps also expanded vendor interest for integration purposes. There is also an industry angle where notable observations could concern expanded breadth, some would argue the proliferation of tools, as well as expanded depth with new features, extended language coverage support, and more. Having said that, a gap has been observed between perceived and evidence effectiveness of security measures that were undertaken by organizations. And this is interestingly inconsistent with the purported increased focus on security. So WhiteSource recently surveyed over 650 developers from Europe and North America, as I mentioned. As part of this was as part of a comprehensive study of the open source development processes, challenges, and as already noted, best practices. What's important is that the study revealed that a negligible percentage of developers, about 3%, roughly 3%, do not employ open source. And among the 96+ percentage who do, the vast majority use it very often or even all the time. The significance of this usage pattern becomes even more pronounced given the dramatically increasing count of reported security vulnerabilities that was observed during 2017. Let's move to the next slide to examine how significant that challenge was. So, as the chart displays, the number of reported open source security vulnerabilities has been increasing over the past 15 years or so. Most notably, the rise was accentuated in 2017 with the number of reported open source vulnerabilities growing by over 50% year over year. It should really come to no surprise that given such a trend, it is becoming increasingly difficult to accommodate vulnerabilities fast enough, and perhaps even more importantly, while preserving development agility that practically all organizations are keen on achieving. But moreover, I think that the rise in the number of open source security vulnerabilities challenges development teams endeavoring to accommodate pressing software developer and software, not just software developer, but the software offering targets. The security vulnerabilities encompass areas such as identity, data, operations. Exploitation of vulnerabilities could critically impact people, services, systems, and organizations. Importantly, and as a result, organizations must be more than ever cognizant about the special characteristics of open source development, because open source security risks are unlike proprietary related risks. They require special awareness of known vulnerabilities and known fixes, in contrast with perhaps non-open source development. This, in turn, highlights needs for extra focus on a raft of things, including detection, publicity, remediation, and scanning. Just one example, perhaps, is the need to implement ongoing monitoring of the reported open source component vulnerabilities, and not just as early as possible, important as is, but also post-software release as well. The significance of reported open source vulnerabilities is also well reflected in open source projects. Let's please move to the next slide to examine how this comes into play. This slide perhaps most importantly conveys alarming information, which is that risk is pronounced with popular open source projects. While roughly 7% of all open source projects have at least one reported vulnerability, many open source security vulnerabilities are well reported for popular projects that are not only very familiar, but are dependable by numerous products. As this slide portrays, the percentage of open source projects with a single vulnerability or more jumps to 32% when the top 100 projects are concerned. It is important to note that while a single reported vulnerability constitutes a potential risk, even a single one, an open source project has 8 vulnerabilities on average. In addition to that, I would contend that one must keep in mind also a few more things. First, maugre the high number of reported vulnerabilities, above 97% of all reported vulnerabilities have at least one suggested fix. The open source community is really doing a commendable job in an attempt to secure open source projects, and as a result, the number of the reported vulnerabilities should really not imply a poor security standards, but rather serve as an indication that a project is actually properly maintained. Developers consequently often spend substantial time over security vulnerabilities. Let's please move to the next slide to examine this effect of such an investment. As the White Source study revealed, developers spend almost 15 hours every month over open source security vulnerabilities. And as this slide shows, over 40% of the developers spend, on average, over 20 hours per month on open source security vulnerabilities. I'm thinking of a better way to put it, something that would perhaps convey it in a much stronger manner. Well, perhaps another way to portray these findings would be that for every developer not investing time in security vulnerabilities, there are, I believe, about 70 who spend some time And perhaps going along the same logic, I would say that more than 10 developers would spend at least one day every week. That is compared to every single developer not investing time in security vulnerabilities, which is quite astonishing, really. But however, and having said that, not only is the cost of open source security rising, so is its significance as perceived by developers, which is really mirrored by these findings. The White House research really revealed that about 26% of the surveyed developers rated security vulnerabilities as the topmost challenge for open source, more than integration, more than functionalities, licensing compliance, and the selection of components. And while this slide really focuses on the time spent by developers over security vulnerabilities, I believe that it is imperative to note that cost is additionally reflected in other, arguably more indirect aspects as well. A largely inefficient developer time usage, perhaps especially given that, according to the White Source study, more experienced developers are tasked with remediation of open source vulnerabilities. And this is important, this in turn potentially results in a couple of things. First, extended involvement of security and QA. In addition to that, delayed feature release. And finally, last but definitely not least, any outstanding security threats that are not addressed early and fast enough. So this definitely adds to the assessed cost. And while commonly spending a substantial amount of time over vulnerabilities, developers appear to employ, well, extremely varied prioritization methods. Let's please move to the next slide to expatiate on that a bit. I think that by observing this display, it would appear that the coloring employed helps prompt an observation that the displayed methods and percentages alone may not easily reveal. One is that only 56% advert to security-related reasons for prioritization purposes. Critically, I would actually highlight some of those examples. One would start with the criticality of the project that might be impacted by the vulnerability, which is about 25%, to be followed by perceived impact of the vulnerability to projects, which is roughly 10% lower than that, and vulnerability severity as well. But this, and this is what's interesting here, this really contrasts with the remaining 44% who advert to reasons that are arguably operation-related in spirit. And this includes availability of the suggested fix, the number of software libraries containing the vulnerability, and even the creation date of the vulnerability. I believe that such findings serve not only to suggest that the prioritization approaches are varied, this would be quite conspicuous, but that critically they are not stemming, or at least not only stemming, from a security-oriented approach. And this might result in an ineffective, let alone inefficient, approach. This ineffectiveness and inefficiency associated with traditional open source security management is also manifested in commonly observed processes. Let's please move to the next slide to examine that. The White Source study showed that a mere 1%, just 1% of the survey developers do really nothing when a vulnerability is found. On the other hand, 99% are either researching to understand the vulnerability. This is basically the majority of that group, over 30%, or reporting it to other teams or remediating it based on available recommendations or on patch availability. Interestingly, while 15 hours per month are spent on average to address the open source security vulnerabilities, only about 4 hours, actually less than that, 3 point something, 3.8 if I'm not mistaken, hours are allocated on average for remediation. And it is thereby observed that steps required to effectively close the loop on remediation processes are not as common as they arguably should be. Despite spending much time over vulnerabilities, companies are unable, so it appears, to effectively enough safeguard solutions, and time spent is not managed efficiently. This is perhaps arguably due to missing tools and best practices, where best practices could include, for instance, that developers are not appropriately involved in the security process, or security-related discussion has a disruptive effect on the development process and perhaps on the resulting agility. Whatever the case is, it is pretty obvious and clear that there are certain aspects, key aspects missing that would otherwise be significantly helpful in promoting the organization's journey towards an effective realization of prioritization and better addressing of security challenges. Let's move to the next slide to elaborate a bit on some of the challenges that organizations typically face. In the context of this slide, I would say that people, process, and technology are often stated as main pillars, or perhaps better put, factors supporting a promoted offering, be it a product or a service. We've already noted early on that open source software development is characterized by special facets that warrant a new approach to people, and perhaps instead of saying people, a role involvement might be more appropriate or more accurate, in addition to tools and to processes that perhaps may have not been similarly employed in non-open source development environments, but are important. Then, the requirement or the importance to discuss such an approach is even accentuated by the nature of open source security vulnerabilities. And I would even point out that the agility many organizations set out to achieve. This is really a key aspect. Challenges associated with the facets of people and process in the realm of the open source security discussion, and perhaps predominantly the prioritization of critical security objectives, these are really these aspects really serve as the focus of this slide. I'd like to say a few words about that. When we talk about objectives, goal attainment, a resource bandwidth, and perhaps importantly, given the topic of this session, prioritization, all of these elements are not identical among the different teams constituting the development environment. Many organizations are challenged by the following questions. For example, who owns security? Who is the owner of security throughout the software development lifecycle? Who owns selection of components? Who owns prioritization? And more importantly, even when, even how do security operations play within the software development lifecycle? This can potentially, and arguably often does, hamper the prioritization and result in friction and delay of releases and so forth. Let's move to the next slide to examine some tool-related aspects as well. Notwithstanding the significance of people and process, technology, or all of the three pillars that were discussed, I think that technology really constitutes a key reason behind an inability to effectively safeguard solutions and even more importantly, manage security vulnerabilities effectively. In order to empower the people with the ability to pursue security objectives, especially in a competitive manner, they must employ tools that will only satisfy the requirements that are driven by such objectives. It's not just the required functions, but the ability to facilitate and streamline operational decision-related processes that would be needed in order to realize an optimal outcome. The absence of appropriate tools and best practices adversely affect the ability of teams to attain the security targets. And prioritization is believed to be a key factor to ameliorate the situation. Let's move to the next slide to review that further. So the key strategy, prioritization of effective vulnerabilities, I think that facing the adversity of inefficient remediation practices has really become a concern. And attainment of the most critical security objectives means, at least in many cases, it means an ability to address the most exigent security vulnerabilities in a timely manner, in a timely manner that mandates the implementation of a strategy which pursues a viable prioritization approach. One such approach promotes the concept of security vulnerability effectiveness. It touts the identification of effective security vulnerabilities as a means to realize practical prioritization. Let's move to the next slide to discuss that further. So there is quite a lot of implied information in this slide. Attempting to solve all reported security vulnerabilities is considered infeasible and in some ways even inconceivable. An attempt to deal with all the reported vulnerabilities would likely present organizations with a need to face more vulnerabilities that they can effectively handle, especially given any agility goals that are set forth. Prioritization is therefore arguably the only viable approach, really the only viable approach to accommodate such an expanding list of vulnerabilities. That said, prioritization is often not really very easy to accomplish. And as already presented early on, companies may employ varied approaches of prioritization, which might not implement security-oriented reasoning necessarily. This would result in an outcome that is often plagued by process difficulties and in inner team friction, even in inability to effectively address the most critical security objectives that were set. The goal really is to reduce the count of security vulnerabilities to the point where security and other objectives can be met more effectively and perhaps even more comfortably. Let's move to the next display. This really represents a build-up on the previous display, and it highlights how focusing on less vulnerabilities, at least from a visual perspective, which is obviously much simpler than in real life, enables better efficiency, effectiveness, and security. However, and this really goes to the point that I wish to highlight here, traditional approaches to reduce the count of highly prioritized vulnerabilities, they often involve subjective arguments and the qualification methods that were challenging to yield some agreement by the teams that were involved in the delivery process. Let's move to the next display to see, or perhaps better said, to discuss some of the aspects that are critical in that respect. So the concept of effectiveness, of vulnerability effectiveness, is aimed to provide a different outcome. Effectiveness really denotes reported vulnerabilities in components that are referenced by proprietary code. So importantly, effectiveness entails both direct and indirect references. This covers direct code dependencies as well as transitive dependencies. Vulnerabilities that are confirmed to be referenced by proprietary code can be easily and justifiably prioritized compared to vulnerabilities that are not so. And this results in an objective manner compared to what I mentioned earlier, the more subjective manner. So this is an objective manner to accommodate the prioritization quandary, if you will. An ability to identify not only which vulnerabilities are reported for a software component that is used by the project, but which of the reported vulnerabilities are associated with a code that is referenced from the application in practice. This really means that prioritization based on such an ability could classify vulnerabilities according to effectiveness, and this would reduce the listing of vulnerabilities warranting immediate attention. The question nonetheless remains, by how much can the listing of reported vulnerabilities be reduced? Let's move to the next slide to find out. The white source research revealed that a prioritization strategy for open source security vulnerabilities can truly help organizations address the vulnerabilities warranting the highest attention I would say in an optimal manner. This would effectively reduce the number of critical alerts by 70%. This is a staggering figure. It is important to note that the 70 to 30 ratio between ineffective and effective vulnerabilities is, by the way, not necessarily an optimal figure. And in fact, the studies that White Source led indicate that in practice, higher ratios, 80 to 20, even 90 to 10, are not uncommon in real-life environments. In projects that were subjected to an effectiveness-based prioritization method, so to say, over 80% were in fact found to be non-effective, which is higher than the otherwise predicted 70%. And furthermore, almost, over 90% of the vulnerabilities were really found to be intransitive dependencies, which really highlights, it emphasizes the significance of effective tracking. What can one learn really from the distribution of effective vulnerabilities, and what is the recommendation? Let's move to our final slide to cover that. The ability to reduce the count of reported vulnerabilities that demand critical attention is clearly a positive outcome of the prioritization process. I would contend that it yields a viable approach for meeting security objectives. The benefits, however, realized by focusing on effective vulnerabilities go much beyond that, because they provide benefits for development, for managers, for decision makers, and most importantly, vulnerability effectiveness, as was captured, serves as an objective means for prioritization. And this really can result in minimized friction among the development teams, development, DevOps, and security teams. It would provide a better ability to streamline remediation processes, realize faster development, lead to reduced QA requirements, and ultimately to improved security as well. I believe that is an appropriate way to summarize the key value and the value proposition for such an approach. Thank you. I would like to hand it now back to Scott.
All right, Rami, and with that, Colleen, do we have any follow-up or feedback on our presentation so far?
Yes, thanks, Scott and Rami. It's now time for our Q&A session. Our first question today is for Rami. What does a real-life method for prioritization look like?
A real-life method. So a real-life method should really allow users to effectively prioritize the handling of reported vulnerabilities. Such a method would be required to combine analysis and management tools, and those tools should, on one hand, enable the organization to determine if any software projects are effectively exposed to reported open source vulnerabilities. I would add to that how they are exposed as well. And on the other hand, it would also be expected that such a method would facilitate a swift assessment and prioritization of vulnerability remediation options. Perhaps to be more specific, the method would enable users to establish which vulnerabilities, which reported vulnerabilities, importantly, are referenced from proprietary code, how and where does the proprietary code make calls that reference code that is associated with reported vulnerabilities, and in addition, also the ability to classify reported vulnerabilities in open source software components based on their effectiveness. This is important. And finally, to expose any results that were obtained concerning the vulnerability effectiveness through reports, through programmatic means. That would be basically the important parts of such a method.
Great. Thank you, Rami. And the next question is for Scott. There's a lot of talk about shifting left and getting developers more involved in building secure code. What are some of the obstacles to that, and how can organizations overcome them?
Yeah, that's very much related to what Rami was describing as far as real-world techniques for dealing with these issues. And I mentioned this earlier in the webcast about shifting left. And what that means, as I alluded then, is we need to address vulnerabilities earlier in the development life cycle. Vulnerabilities exist because they've been implemented by someone somehow. They can be implemented in the source code on which software is built. They can appear once that code is compiled in the way that the code handles interactive input, for example, in the exposures that a container has before it's deployed in operations that exposes vulnerable components to a network, to a public network, perhaps, in which case they can be exploited remotely. So by shifting left, we're trying to get these issues dealt with as early in the development life cycle as possible. And a lot of times that means shifting the emphasis on the developer themselves or to the development team to be aware of vulnerability issues before they're incorporated in source code. So we do that through education, training, and awareness, helping developers become more literate about security issues so they're aware of them and don't actually implement these vulnerabilities as they're building source code. There's a few ways to deal with that. One of them, as I mentioned, through education, providing educational materials directly to developers, but doing so in a way that's very easy for them to access, either on their development platform or integrated with their IDE. We do see IDEs right now that point out code implementation issues as the code is being written. The same sort of approach can be applied to pointing out security issues as source code is being written. Developers can also run an evaluation of their source code through static analysis that's done just on their local development, what the modules that they are working on before they're checked in repository or integrated with the primary or master release of a branch of software that they might be working on. And that points up one of the key issues for adoption. We have to reduce the friction of adoption, the friction of embrace of better security in development to make it something that developers can actually use. And another issue, as Rami was pointing out in the discussion of effective vulnerability, is we can't hit the brakes on agile development. Organizations have an imperative to get functionality developed and out into operations typically as fast as possible. And a lot of times that means that security issues can be run roughshod over with the anticipation that they'll be dealt with in a later release along with other quality-related issues, for example. So we have to make these approaches a lot more amenable to these agile, meaning fast development pipelines. They have to integrate more natively into the processes that developers use to build technology, which means they have to be interoperable with and compatible with the tools and processes that these organizations are using to accelerate and streamline development as much as possible. So again, getting back to Rami's discussion of effective vulnerability exposure and limiting the amount of work or rework that has to be done on software as a result of that, that increases the efficiency of these organizations and helps them to develop really not only better quality code, better quality software, but more secure software as well. And I have a feeling, Colleen, that might be the last question that we're going to have time for today.